Friends, now I am going to show you how to solve a cantilever beam with UDL and point load. So in this problem you have combination of loads, UDL and point load, and I have solution here. So after solving, force at three different points. See, take this point as A. I will take this point, starting point as A, B and C. Force at A will be 2 kilonewton. B is also same. So when we reach from B to C, last fixed point, so the load is uniformly distributed so that we are getting SFD like this. Similarly, after calculating bending moment, so we will get moment at A is equal to 0. Moment at B is load into distance, that is 2 into 4 minus 8, since load is hogging, bending moment is creating. So then moment at C will be 18 kilonewton meter. So now how to solve this problem using ANSYS? Just look at this one. So I will go to clear this image. So I will zoom it a bit. So already I have opened ANSYS software. Let's start using ANSYS software. So first preferences, then go to structural, click on OK. Go to preprocessor, element type, add, edit or delete. So here you add. Since we are solving beam problem, select beam. In that one you select 2 node, then click on OK. So beam is selected here. Close this one, then come to material properties, then material models. So as per the given problem, so cross section area is 200 into 300 mm, Young's modulus and Poisson's ratio is given. See, one point I have to tell you. So ANSYS will not take any units automatically. That means there is no option to set the units in ANSYS. So whichever the unit, if you are convenient, that one you are supposed to select. See here. So here the problem is solved in kilo and newton. That's why we have to put the load in kilo only. So and the length is in meter. See, in bending moment we have did kilo newton meter. So you should be careful while selecting the units, okay, because ANSYS doesn't give you any unit settings clearly. So your Young's modulus is given. And one more point I have to tell, some students are telling that sir, the app will stuck in the middle. Actually that is not the problem. What will happen when we do multitask like this, opening and closing on another app, or when we do some other things, the dialog box or this one, the options will hide somewhere. So to avoid that one, see, in front of the command text box here, rise hidden option is there. You have to click on that one. So if some options are hidden, it will reappear. Then you have to perform particular operations. So let's moving on. So I have to select structural, linear, elastic, isotropic. So EX value, Young's modulus is given 210 10 power 3 E3. So then Poisson's ratio is given as 0.27. Click on OK, then close this one. Then come to sections. So select beam, common section. Here beam section is given as 200 into 300. Mostly, just I will check it again. Yes, it is 200 into 300 cross section area of the beam. It will be given in the problem. Click on OK. Rectangular cross section you have selected. Then go to modeling. So beam is selected. Then directly go to modeling. Create key points in active CS. So key point number 1, that is fixed. You select 0. Click on apply. So because this is fixed point starting, there is no distance 0. Then point number 2 is at a distance 2 meter. I will put the value in meter only, 2 meter. And 3 is from this fixed point, total distance, that is 6. Here key point number 2, that is at 2 meter. Click on apply. Then key point number 3, totally that is at 6 meter. Just go through carefully. So from this point 2 meter plus 4 meter. Key point number 3 is this one, totally 6 meter. Key point number 3 at 6 meter. Click OK. On screen you can see number 1 here, it is little bit hidden. So 2 and 3. So all key points are created. Then go to lines. So in lines again you select lines, straight line. Click on point number 1 to 2. Then 2 to 3. Line will be created. Click on OK. So line is created. We have to mesh this one. Carefully look at the meshing option, because while solving some other problem, we followed some other meshing methods of directly entering value, but while solving the problems related to UDL especially, or you can follow this method for all the problems. See, while meshing, you have to select meshing, then you have to select mesh tool. So when you select mesh tool, one dialog box will appear. So in that one, you have to select lines. Carefully observe lines. You select set. So after set, you select both the lines. Click on OK. So then one more dialog box will appear. In that one, element edge length, you no need to enter anything. Number of element divisions, you enter 100. You can enter any value. When value is more, you will get a smooth curve. I will enter 100. Click on OK. See, now actually we are already in one menu, that is mesh tool, but menu is disappeared. To ensure that one, you click on raise hidden button. So just if you observe the screen carefully, the line is divided into small parts. That means 100 divisions it is divided. We have to mesh it. Again in the same dialog box, same menu, you select mesh option. Again the mesh lines option will appear. You select both the line, click on OK. So you will get a straight line without key points. You have to ensure this one. The key points will automatically disappear and you will get a straight line. That means divided line is meshed again. So to apply the load, we want key points. For that, what you have to do? Meshing is completed now. You go to plot control, numbering you select. In that one, key point number off is there. You put tick mark on, checkbox you put it on, then click on OK. So what will happen? Just I will cancel. Plot control, numbering, apply. See, it will reappear this one. You have to close this menu first, then click on OK. So number is not appeared. So if number is not appeared, go to plot, then go to key point, show key points. Okay, so number will appear, then go to lines. So again the line will appear. Don't confuse with this line because this line is already meshed. Okay, so after meshing, the number was disappeared. For that one I did. So here plot control and numbering method you can follow. Here also in plot also you can just put key points, only key point will appear. Plot you put lines and key point both will appear. So now I will move on to next step. See, I am remembering you, carefully operate meshing tool. So once again you ensure any dialog box or menu is hidden by pressing raise hidden button, then close that one. After that, go to loads. As you know, define load, apply structural. Since in the given problem this is fixed, up to here UDL and at the end point load is there. So I will select displacement on key point, select first key point, go to apply, select all DOF, click on OK, all degrees of freedom fixed. Then, so from here to here, number 1 to 2 there is UDL. How to put UDL? For UDL you have to select pressure on beam. Carefully follow the step on beam. See, we can select each and every point of the beam, but there are more number of points. For that I will click on box. Carefully look at this one, box option. Then I will select from box, just like a box. I will draw a box from 1 to 2. It is selected. Click on apply. Carefully observe here load key. Load key 1 is appearing. You have to 2. 2 means the load is acting downward. Carefully, since load is acting downward, you have to put 2. Then pressure value at node I. Node I, that is 3 kilonewton per meter. Only enter 3. There is no value for this one. Okay, see, menu is hidden. Again I will press raise hidden button. It will appear. So there is no value for J. Only node at I is 3. Click on apply. Okay, see, the UDL is applied. So you can close this one, close this one. So now we have to apply one point load here. So you can just go to zoom it and you can observe. When you zoom, it will disappear. If you want it back, go to plot and click on multi-plot. It will appear again. Okay. Then last one, we have to apply point load. For that, force bar moment on key point. Click on the end point. Click on apply. So here load is acting in y direction. Since it is negative, we have to enter minus check the value, minus 2 kilonewton. That's why I will put minus 2. Okay, minus 2, and click on OK. The load is here. So loading is completed. Then go to solution, solution, solve current ls. Wait for a few seconds. It will show. Click on OK. Solution is done, should appear. When solution is done, is appeared on screen, so your 90% of the problem is solved. So now only thing is that we have to get SFD and BMD. For that one we have to go for general post processing. So before plotting the result, we have to select element table, define table. In that add, you try to add by sequence number. SMISC is selected, you enter number 3, click on OK. So you will get some error message. Don't worry, close this one also. You press rise hidden. If any menu is there, you close that one also. In command box, you type set comma last, set comma last, and press on enter key. Again try to define the table. Define table, add by sequence number, SMISC, select number 3, click on apply. Next, again by sequence number, SMISC, next number is 6, apply. See, number is appeared here, 3 and 6 appear. Select once again by sequence number, SMISC 16, apply, and last combination by sequence number, SMISC 19, click on OK. Last step. See here, as we know in ANSYS, the 3 and 16 combination is used for BMD, 6 and 19 is combination is used for SFD. Close this one. Again come to plot results. In that one counter plot, in that one line element result. So as I told, select 6 and 19 combination for shear force diagram. See, clearly look at this value. This is shear force diagram as we have drawn, but exactly we are getting mirror image. No need to worry, you just clarify the value. Force at A is 2 kilonewton, B is 2 kilonewton, and FC is 8 kilonewton. So here we have to get the values 2 kilonewton, 2 kilonewton, and 8 kilonewton either in positive direction or in negative direction. Let's zoom this value. Here we are getting 2. That means this position is 2. This position is also 2. Here maximum value is 7.91. That means here we have got 8 value. There is small error. No need to worry. It is approximately equal to 8 kilonewton. So this is our shear force diagram. Then again for bending moment diagram, again select line element result, select the combination 3 and 16, alternate combination. Okay, see, bending moment diagram is exactly matching. Just go through the values of our theoretical values. Here value is minimum 0, so this point is 0. This is this, if this point, this is 8 and maximum is 18 we are getting. Just go through the value. Here we are getting 17.80. Obviously there is some error in analytical and system based solutions. No need to worry. So then, so how to get the value 8? See here, if you clearly observe the diagram, I will zoom the diagram. Up to here, up to this green mark, there is a value, curved value. Okay, see here, look at this screen. Up to here, straight line we have to join, slant line. After this one, curved line. So if you observe in this image, here also the curved line will appear from here. So that carefully observe. So up to this one there is a green shading. So if you observe the green value here, it is 7.9. That means approximately 8. So the value is very near. Sometimes we will get exact values. This is based on the starting values. Okay, I have taken Poisson's ratio 0.27 here. If you take 0.3, you may get the exact answer. So this is the solution for simply supported, this is the cantilever beam with the combination of loads, that is UDL and point load. So to get the printout, you can just reverse this screen, go to plot control. In that one you go to style and colors you select in that one reverse video. So at that time what will happen is the background will become white. So again you can go to plot control and capture image. It will capture like this. You can go to file and print, or you can save this for the further reference. So thanks for watching this video.